Okay, so let's do an example of 3D rigid body equilibrium. Okay, so I have this system right here where I've got a ball and socket joint at A, I have a weight of 150 wrapped around a drum right here, and I have a bearing right here at B, and I have applied force right here. Now the problem statement says that I'm properly aligned, so I only have to worry about the forces at B, not the moments, because generally this bearing could restrict motion about the z-axis and the x-axis. Okay, but if it's properly aligned, we can neglect those, and if we didn't neglect those, we'd have too many unknowns for us to solve with our equations. So my free body diagram will look like this: ball and socket joint at A, okay, rotation any which way I want to do it, okay, however I can't have any translation, okay, so there's no moments, just a bunch of forces at A. Got my 150 acting straight down right here. We talked about B, okay, that I only have the forces here. I am free to move along the y-axis, so I just have the z and the x components, no moments because it's properly aligned. And then I've got my force P acting in the x direction right there. Okay, so got my free body diagram. Next step is to apply my equilibrium equations. I'm actually going to start with my moment equation here, and I'm going to sum my moments about point A, and the reason I'm going to sum them about point A is because I have 3 unknowns there. That leaves me 1, 2, 3 unknowns that will actually show up in my moment equations, which I will be able to solve because I have moments in 3 directions. However, I'm going to sum the moment in 3 dimensions at once. Okay, so again, I'm summing about A, so I have R cross F 3 times, and that's because I have forces. I have the 150 here, I have 2 forces at point B, and then I have the force P. Okay, so I have those 3 different R vectors from A to each of those forces. So we'll start with the 150. Okay, the R vector is the radius of the drum in the x direction, and then 2 feet down the y-axis. So I get 0.5 I plus 2j crossed with the negative 150 in the k direction. Okay. The next forces I have is B, which are 4 feet down in the y-axis. So I have 4j crossed with my 2 reactions at B. The free body diagram here has bx going in the negative x direction. That's why this negative's here, plus bz in the k. Last one is this P force, which is 6 feet down the j-axis, and then negative 1 foot in the z direction. So I get 6j minus 1k crossed with P in the I direction, because P is in the x direction. Okay, so I've got those 3 cross products I need to do, and I'm going to do those in 3 dimensions, which I have here. So this cross product, I get the 0.5 cross negative 150k, that gives me the 75j. 2j cross negative 150k gives me the negative 300i. Then I have 4j cross negative bxk, that gives me the 4bk. bxk. Then I have 4j cross bzk, that gives me the 4bzi. 6j cross pi gives me the negative 6p in the k direction. Negative 1k crossed with pi gives me negative p in the j direction. So that is all of those cross products. Okay, so I have one 3-dimensional moment equation here. Okay, however, these are actually 3 individual equations. I have the x, y, and z components, right? So I pull out all the i's, pull out all the j's, pull out all the k's. Those all have to equal 0 because of equilibrium conditions. So in the x direction, I have negative 300 plus 4bz equals 0. That means bz equals 75. Those are my I components. Do the same thing with my j components. I have 75 and I have negative p. So 75 minus p also equals 0 because it's an equilibrium. P equals 75. Finally, I have 4bx in the k direction minus 6p in the k direction. So 4bx minus 6p also equals 0 because it's an equilibrium, means bx equals 112.5. Again, I know that p is 75 plug that in, I get Bx equals to 125. So those are my moment equations. Again, the best way to deal with it in 3 dimensions is actually do the moments doing the 3-dimensional cross product and then break it out. Okay? Rather than trying to figure out, which force creates which moment in what direction. So once I've done that, now I'm going to move on to my force equations. I have the sum of the forces in the x equals 0. So I have ax, I have negative bx, that's the negative 112.5. And then I've got p, which is positive 75. Again, that has a sum up equal to 0, so ax is 37.5 pounds. Some of the forces in the y direction, I have ay. I'm sorry, ay is in this direction. And that is the only force I have in the y direction. So I know that ay has to equal 0, because some of the forces in the y has to equal 0. Finally, I have the sum of the forces in the z direction. Okay, so I have az, I have negative 150, and I have bz, which is 75. So az plus 75 minus 150, that means az equals 75. So again, process, free body diagram, figure out your forces, remember your reactions, sum the forces in the x, y, and z directions, and then sum the moments, set them equal to 0, and do that in all 3 dimensions at once, then pull out your x, your y, and your z components of your moments, setting them all equal to 0 for equilibrium. Then solve all 6 equations for up to 6 unknowns.